Good afternoon. Today is Wednesday, November the 11th. Today in geometry, we talked a little bit about congruent triangles and the method of proving congruency, which is side, 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 and side angle side. So I'll show you a couple of examples of each one of these. So come in here to the whiteboard. If you look, a problem we can have here, if I draw a picture, I've got something that looks like this. And then I got something that looks like this. And I can come back into about right here. And then go up here. And go from here back to here. Now, so if I set this up, this is going to be L here. This is going to be M here. This is going to be N here. And this is going to be P. Now, in my given information, I'm going to tell you here that side LM is congruent to side LP. And I'm going to tell you that MN is congruent to PN. Okay? Now, and what I have to do here is I have to prove that triangle LMN is congruent, and I'll put the congruent sign to triangle LPN. Now what we have two techniques to prove. One is a side, side, side technique. Side, 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 that's abbreviated SSS. And the other technique is a side angle side, which is abbreviated SAS. Now, so when I'm looking at trying to prove here, I'm trying to prove that triangle LMN is congruent to triangle LPN. So I'm looking at which one of these two techniques I want to try. Now, what I have here is I have one pair of sides here, LM and LP. I have a second pair of sides here, which is MN and PN. And my third side is right down the middle here, and it's the same side for both triangles. So that's what we have, which is reflexive. So I can come in here and I can say, basically, I'm given the other two sides, so I can make a statement here that says LN is congruent to LN, and the reason is reflexive. Okay, so if I come in here now and I put the congruency symbol, I put the congruency symbol up above here, and I put the congruency symbol up above here. Now, so when I have this completed, my given information is this pair of sides congruent and this pair of sides congruent, and my statement is that LN is congruent to itself. That's a reflexive property. So therefore, what I have done here is I have shown that triangle LMN is congruent to triangle LPN, and the reason there is because of side, side, side. Now, if you look, we talk about something called the congruency statement, and the congruency statement is right here. In this case, it's triangle LMN is congruent to, so if I come down here, let's do this. Let's come down here. So I'll show you a congruency statement. I can put the triangle symbol in there. So I got LMN is congruent to triangle LPN. Okay, so if I come back now and draw my triangle here, so I got triangle LMN is congruent to triangle LPN. Now what this says, this is a congruency statement. So it says angle L is equal to angle L, which is that little angle right there. Angle M is equal to angle P. And then angle N is equal to angle N. So that angle and that angle there are equal. And then I know that side LM is congruent to side LP. I know that side MN is congruent to side PN. And I know that side NL is congruent to side NL. So that is a side-side-side congruency. Now, I'm going to erase this. If you want to check this a little bit longer, you could pause your video at this time and look at what this says. I'll go ahead and erase this and show you an example of a side angle side congruency. All right, so we're going to come down here and I will draw basically a rectangle here. So I'm going to draw like this. And I'll come down like this. And I'll come across like this. And I come from here up to here. And I'll draw a diagonal down through the middle here, okay? Now, and this I can come back and make this, so this is going to be A, this is B, this is C, and this is D. Now, I'm going to give you that AB is congruent to CD, and I'm going to give you that angle BAC, which is right here, is congruent to triangle DCA. Now, so what I have here, if you'll notice, I have a side and an angle. And the thing that you'll always kind of be looking for in these proof type situations is right down the middle here, I have AC equal to AC. So what I'm trying to prove here, I'm trying to prove that triangle BAC is congruent. So this is my congruent symbol to triangle. And see, I got to keep it pit. So BAC, so D goes with B, C goes with A, and then A goes with C. Right now. So now if I do this, see the bottom triangle here and the top triangle, I have a side and a side. So I have one pair of sides and I have one pair of angles. And when I do a side angle side congruency, the angle has to be between the two sides. So if you'll notice, see, I've got my side here, and my angle here. So then the other side needs to be that AC right up the middle. And so see, I have that third side. I can say that AC is congruent to itself, which is what this is. So AC is congruent to AC, and the reason is because of the reflexive property. It's reflexive. REFLEX. I won't spell the whole thing out, right? So what I've shown here, notice, well, we can go ahead. IVE. Right? Now, so what I've shown here is I have a pair of sides, a pair of angles, and then right down the middle here, I've got AC equal to itself. So I have a side angle side equal to a side angle side. So I have proven that triangle BAC is congruent to triangle DCA. And the reason I would just put right out here beside it would be side, angle, side. So if you look at the examples in your textbook in this section, tomorrow we'll work some more proofs in class, basically just doing exactly what we're doing right here. And then Friday we will have the mid-chapter quiz for chapter 4. So that's something you can be working on. If you have any questions, send me an email and I'll get back to you. So I'm going to stop sharing here now and go ahead and end the recording.